Mass spectrometry is one of the methods by which we can analyze molecular weight of a charged molecule. It separates molecules by mass to charge ratio, and also it detects charged or ionized molecules in the gas phase, and charge comes from protonation events during ionization. Let's understand this. Mass spectrometry basically is an analytical tool which is useful for measuring mass to charge ratio of one or more molecules present in a sample. These measurements can often be used to calculate exact molecular weight of the sample. Typically, mass spectrometers can be used to identify unknown compounds via molecular weight determination. In a mass spectrometer, we use protein or peptide samples which involve weak or soft ionization, which means you need to ionize your protein sample first so that you can get the results. This is how a mass spectrometer looks like. Now let's understand how does a mass spectrometer work. There are three components in the mass spectrometer: ion source, mass analyzer, and detector. The first step, you put your sample in the sample inlet and vaporize it. Molecules are converted to gas phase ions in the ion source so that they can be moved about and manipulated by external electric and magnetic field. Remember, there are two types of fields used in mass spectrometer, that are electric field and magnetic field. Ion source in which you do ionization can be of two types, ESI and MALDI, and this we'll learn later. Now, once you put your sample in the ion source, these molecules are converted to gas phase ions, and this method allows for creating positive or negative charges depending on the experimental requirements. Next is the mass analyzer. Once the molecules are ionized, the ions are sorted and separated according to mass to charge ratio, and there are a number of mass analyzers available nowadays. The mass analyzer often works with the ion detection system. In the ion detection system, the separated ions are then measured and sent to a data system where M to Z ratios are stored together along with their relative abundance. A mass spectrum is simply, this is a mass spectrum, it is simply the M to Z ratio of the ions present in a sample plotted against their intensities. Each peak, what you see here,